Okay, when you're graphing these reciprocal trig functions, what you're going to want to do first is graph the trig function. So whenever sine of theta is 0, the cosecant of theta function is undefined, so there will be an asymptote. So whenever there's an undefined value, there's going to be a vertical asymptote. Whenever tangent of theta is equals to 0, because the cotangent of theta is undefined, so there again will be an asymptote. So tangent of theta, or cotangent of theta, is equal to 1 over tangent of theta. So if wherever tangent of theta is undefined, which remember tangent's undefined on the y-axis, then there's going to be an asymptote on the cotangent function. Whenever cosine of theta is equal to 0, the secant of theta function is undefined, so there will also be an asymptote. So when I'm graphing these reciprocal functions, first I'm going to graph sine of theta in order to graph the cosecant of theta. So sine of theta is at negative pi over 2. The value is negative 1. At 0, it's 0. At pi over 2, it's 1. At pi, it's 0. At 3 pi over 2, it's negative 1. And at 2 pi, it's 0. So that means my asymptotes are going to be, for the cosecant of theta, the cosecant of theta is undefined here. So I'm going to continue the pattern on to the left here, negative pi, negative 3 pi over 2, 2 pi, and draw my sine function. Okay, got sloppy right here. Okay, so I'm going to draw my sine function. And then for my cosecant of theta, I'm going to draw in the vertical asymptotes. So there's going to be a vertical asymptote whenever it's going through the 0. Okay, another thing that I'm noticing is that if you take the reciprocal of negative 1, it's negative 1. 1 divided by negative 1, 1 divided by 1, or 1 divided by negative 1. So these points, the 1s and the negative 1, it's going to be your other intersections, or your other points on the cosecant graph. The next point I'm going to get on this graph, because secant will be the same, will be very similar as the cosecant, is I'm just going to check what the sine of 30 degrees is. So remember 30 degrees is pi over 6. So sine of 30 is in a reference triangle. It's going to be 1/2. So the reciprocal of that is going to be 2. So if I go over pi over 6, which would be, this would be pi over 4. So if I go over pi over 6, it's going to be about right here. And if I go up 2, it's going to be right here. Now, because the cosecant function is periodic as well as the sine function, the same point is going to be over here at 5 pi over 6 is also going to be 2. So now I can make this function. It's going to keep going up and up and up right here, because as you're getting closer and closer to 0, because you're dividing by a number that's getting larger and larger. So this pattern continues on. Okay, you could put it in your graphing calculator and see, but this pattern continues on. Looks like this. And then this one. And then up here. So the cosecant function is the function in blue. Okay, now I'm going to graph the secant. So the secant, I'm going to do it by graphing, just like I did the sine, I'm going to graph the cosine. So the cosine at negative pi over 2 is 0. Oh, I'm sorry. Wait, negative pi over 2. Yeah, and then at 0, the cosine is 1. And then at pi over 2, cosine is 0. And then at pi, it's negative 1, 0, 1. So again, right here is where it's going to be undefined, the secant. This is where you're going to have an asymptote. And then this value will be 1, negative 1, 1. So I'm going to go ahead and graph the asymptotes. The asymptotes are going to be at pi over 2, negative pi over 2, pi over 2, and negative 3 pi over 2. So the period of this function up here is actually 2 pi. Sometimes people think the period is just one of these, but the period has to include a right side up u and an upside down u. So the period of these is 2 pi. Same with over here. So again, I'm gonna graph the cosine function. So cosine function starts at 1, 0, min, 0, max. And then it's going to do the same pattern here on the left. So to graph the secant function at negative pi, negative 1, it's going to open down. Here it's going to open up. Here it's going to open down. Here it's going to be half of a quarter of a cycle over here. So that's the cosecant function. And you can also, or that's the secant function, you can also graph the cosecant and the secant function in your calculator by putting in your y1, 1 over the cosine of x. That's going to graph y equals secant of x. And so just like how this is written from negative 2 pi to 2 pi, you would want to make sure your window is going from negative 2 pi to 2 pi. Okay, then let's do the cotangent one. So cotangent, I'm going to look at the tangent of each of these. So the tangent's undefined. The tangent of 0 is 0. This is undefined. Tangent of pi is 0. This is undefined, and this is 0. Well, that barely helps us, but we do know that it's going to be undefined right here. So I'm going to graph the cosine function, or the tangent function. So remember, the tangent had vertical asymptotes going every pi. So these are the asymptotes for the tangent function. And the tangent function, I'm going to graph, looked like this. So 0, negative 1, 1, 0, negative 1, 1. And then this is a half a cycle. And this is a half a cycle. So I can go back to my table right here. So this graphing the tangent function really helps us out with the cotangent because this is kind of going to get ugly, but whenever tangent is 0, there's an asymptote for the cotangent. So I'm taking a different color and drawing in where my cotangent would be, where my cotangent would have a vertical asymptote. Right here. So if you remember how we did the reciprocal function, if your tangent value is 1, the reciprocal of 1 is 1. The reciprocal of negative 1 is negative 1. So with a different color, I'm going to put 1 and negative 1. So I'm going to darken over other values where it would pass. So this is what And the cotangent function will have a 0 where the tangent has an asymptote. So really, cotangent looks like tangent. So here's what cotangent does. It's got an asymptote and it crosses through these two. So keep your eyes on the blue part. I know it's getting really messy, but your cotangent is the blue part of the graph. So I'm going to finish the blue part over here. Those are cotangents. So cotangents are going down the opposite way. So just look at the blue part. These are cotangents. Now, to graph cotangent in your calculator, you would graph y equals 1 over the tangent of x. That's going to graph the cotangent.